Hello friends, this is Jim with Science Talk. I have a alarming report to share with you. Let me give you the headline. Antarctic sea ice is astonishingly low this melt season. Because right now, as I make this video, it's January, which is summertime in the southern hemisphere. Right now on the shores of Antarctica, there's open water slamming against the largest ice shelf in the world, the Ross Ice Shelf. The annual ice-free season has begun at the Ross Ice Shelf a month ahead of schedule. So, what's going on here? Frozen region of freshwater ice, which is approximately the size of France, partially protects the West Antarctic ice sheet from collapsing into the sea. In recent years, the ice-free season in the Ross Sea has become a routine event, but it happened this year on New Year's Day, the earliest time in history. Now, I've done stories before for you in the past where I talk about how the sea ice around Antarctica helps hold back the land ice of Antarctica from, collapsing, dumping, migrating into the sea, where it calves off, and then you have these big chunks. Currents move them into warmer waters, they melt, sea levels go up. So Dr. Cecilia Bitz, who is a polar scientist, University of Washington, states, Antarctic sea ice extent is astonishing low this year, not just near the Ross Ice Shelf, but around most of the continent. So not necessarily a local phenomenon. In recent years, scientists have set up seismic monitoring stations on the ice shelf to track the wave energy as it moves its way inland. And the reason that you have this wave energy, it could cause potential stress fractures in the Ross Ice Shelf itself as it moves along the way. Dr. Bitz pointed to low ice concentration also happening right now in the Munson Sea, which is about more than 1,000 miles away from the Ross Sea. And there's potentially even more worrying. That's potentially more worrying. In a worst case scenario, keep going what humans are doing, West Antarctica, the ice shelves all across West Antarctica could collapse within decades, melted not just from above, but from also below as ocean waters warm, plus wave action smashing them. Then, were that to happen, it's just a matter of time before the massive land-based glaciers in West Antarctica, like the Thwaites and Pine Island, collapse as well. And I've done stories for you in the past discussing those two glaciers. They kind of call them doomsday glaciers because if they were to melt, conservatively, sea level could rise by 10 feet or more. Conservatively. Across the entire continent, there are more than 750,000 square miles of sea ice missing, which is a record deficit for this time of year. Because it is approaching midsummer in the southern hemisphere, Antarctica will keep shedding sea ice for about another 6 weeks or so, and is currently on pace to drop far below the all-time record low set in 2016, just a little over 2 years ago. Now, if you contrast that, one of the first things we learn in polar marine science is compare Antarctica and Antarctica. Antarctica is land surrounded by sea. The Arctic is ocean surrounded by land. So if we look at the Arctic, okay, ocean surrounded by cold continents, and it seems that the Arctic has already passed the tipping point. Sea ice there has been declining sharply for decades. So much so that a year ago, scientists declared the start of a quote-unquote new Arctic, with conditions likely unseen in at least 1,500 years, probably much, much longer. Now, I also did a segment for you some time ago, a little while ago, talking about how the Barents Sea is starting to look more and more like the Atlantic Ocean. In other words, having physical features more like the Atlantic Ocean versus the Arctic Ocean. So you can go back and check out that video if you, again, or if you haven't seen it at all in the first place. So looking at taking a moment to look at the Arctic, sea ice in the Arctic has been declining. The maximum southern extent, typically occurring during wintertime, is not as far-reaching as it used to be. It used to get down through the Bering Strait into parts of the Bering Sea. Not really happening anymore. The average thickness is declining. There is more and more loss of multi-year sea ice. It used to be some of the sea ice would persist for 3, 4, 5 years or more. Now we can barely get 1 or 2 year sea ice, hardly 3-year sea ice, still some around, but hardly any sea ice that's older than 2 years, which means it's, again, the older it is, the thicker it is, but also there are certain characteristics of the sea ice. The older it is, the less transparent it is, meaning that less heat can go through the ice into the water, i.e. more heat is reflected off the ice surface, the albedo effect, which would then, cool things down. So you have 1 year, 2-year-old ice, it's more transparent, so a lot more of the energy will reach through the ice into the water. And couple with that the fact that the sea ice itself is not as extensive, so that there is more open water, well, the water is definitely going to be absorbing a lot more of the energy. This is one of the main reasons why the Arctic is the fastest warming spot in the planet, a region in the planet. One of the main reasons why Alaska has warmed by close to basically 4 degrees C over the past 40 years, because of more open water. You absorb the heat, that's going to affect weather patterns, it's going to affect wind patterns. So there's a lot of things, a lot of domino cascading effects that goes on. So going back to Antarctica, okay, sea ice in the Antarctic region has long been considered something of a climate wildcard. A sharp decline in the Antarctic began only two years ago. This is talking about the sea ice. Scientists don't know if it will continue, but if the earliest indications of 2019 and the rapidly warming Southern Ocean is any indication, it will. Okay? So, and keep in mind, I'm going to be preparing a video on Milankovitch. The Southern Hemisphere, when the tilt of the axis of the Earth is pointed most directly at the Sun, occurs during aphelion, which means the point in the Earth's orbit is furthest from the Sun. Okay? Winter time in the Northern Hemisphere, the axis is pointed furthest from the Sun, occurs at basically, excuse me, I have this backwards. Sorry, I have this backwards. Okay. Keep in mind that winter time in the Northern Hemisphere, where the axis of the Earth is tilted furthest from the Sun, is occurring at perihelion. Okay. The perihelion allows us to have some milder winters than what happens in the Southern Hemisphere during their winter, which occurs at aphelion. Perihelion is when the Earth is closest to the Sun. Aphelion when Earth's furthest from the Sun. That's why the Southern Hemisphere gets more brutal, colder winters, but also hotter summers. So because of the hotter summers, and the base of the Southern Hemisphere is pretty much ocean, the waters around there are really heating up. Now we have currents moving further south, so we have these warm waters degrading underneath the land ice, melting that from underneath there, as well as preventing the sea ice from freezing and forming. So I'll be doing a Milankovitch feature where I discuss all that, how the positioning of the Earth in its orbit affects heat distribution and so forth. So that's why in summertime for the Northern Hemisphere, when we're tilted right at the Sun, but it occurs at aphelion, it's not as hot as it can be. So, and again, the sea ice holds back the land ice. As stated, for less sea ice, more land ice breaks off. Now, here's another interesting statistics for you. I saw this in another report. Land ice is melting at the rate of 14,000 tons per second. Antarctica is losing 600, sounds like the devil's number, right? 666 billion tons of ice every year. That's from the land. That's a large amount. So I wanted to bring you that updated report on what's going on in Antarctica. And stay tuned, right? Things are getting interesting. You know what I mean? Thank you for your time. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.